Let's compute some probabilities, expected value, and variance for a very simple type of random variable called a Bernoulli random variable. So if x is a random variable that has sample space just 0 and 1, we usually call 0 and 1 failure and success. Then we call x a Bernoulli random variable. So there's only two probabilities involved. Let's write little p for probability that we have a success, and then I guess 1 minus p is going to be the probability that we have a failure. So for example, let's say we toss a fair coin. And let's call h a success. Then p is 1/2. Another example, let's say we roll a pair of dice. And let's call 5 a success. Then this probability of success is number of ways to get 5, which is 1 and 4, or 2 and 3, or 3 and 2, and 4 and 1. So there's 4 ways. And then there's 36 things that could happen if we roll 2 dice, so that's 1/9. There's another example. Let's choose 3 marbles from an urn. With, let's say, 4 white and 5 blue marbles. And if we get, let's say, 1 white and 2 blue, we'll call that a success. And p is the number of ways to get 1 white and 2 blue. Well, we've got 4 white and 5 choose 2 ways to get the blue ones. Over, there's 9 total, so 9 choose 2. So that's 4 times 10 over 9 choose 2 is, I'm sorry, 9 choose 3. 9 times 8 times 7 times 6 factorial over 3 factorial 6 factorial. 3 factorial cancels the 9 and 8, leaving us with 3 and 4. So 3 times 2. We've got 3 canceling part of the 9 and 2 canceling part of the 8. So we've got 3 times 4 times 7, which is 12 times 7. Actually, I'll just leave it as 3 times 4 times 7 because the 4s are going to cancel. So I guess we have 10 over 21. Alright, so any experiment where we have a success and a failure, oh, I'm sorry about the glare there. This just says call. Call h a success. Alright, I fixed that. So let's compute expected value and variance. So the expected value of x is 0 times the probability that we get 0, which is 1 minus p, plus 1 times the probability that we get 1, which is p. 0 plus p is p. The expected value of x squared is 0 squared times the probability we get 0 plus 1 squared times the probability we get p, which is the same thing because 0 squared is 0 and 1 squared is 1, so p. The variance is expected value of x squared minus expected value of x, that quantity squared. Expected value of x squared is p. Expected value of x is also p, so that's p minus p squared, which is p times 1 minus p. So for coin toss, we have expected value of x is 1/2. Variance of x is 1/2 times 1/2, which is 1/4. For rolling a pair of dice, p is 1/9. So the probability of success is the probability we get a 5 equals 1/9. So the expected value of x is 1 for success, 0 for not, is 1/9, and the variance of x is 1/9 times 8/9. So 8/81. And then in the example where we're choosing 3 marbles, probability of success is 10/21. So p is 10/21. Expected value of x is p, 10/21. Variance of x is p times 1 minus p. So it's 10/21 times 11/21. So 110/21 squared, whatever that is. And that's about all there is to Bernoulli random variables. The end.